Welcome to the second part of the What's New for Oracle and .NET presentation. My name is Alex Key. I'm a product manager here at Oracle working on .NET development. And for the next hour, we'll talk about the additional Database 12c and ODP.NET features we've introduced in the past year or so. In the first hour, we had discussed the upcoming ODAC release, new features for Visual Studio with support for Oracle Multi-Tenant and Schema Compare, and then also ODP.NET Managed Driver, the fully managed data access driver. In this hour, we'll talk about 4 new topics. NuGet support, that allows you an easy way to install, acquire, and set up ODP.NET and ODP.NET for Entity Framework. Entity Framework support itself, which includes new features for EF6, Code First, and Code First migrations. We'll talk about the ease of .NET development with some of the features ODP.NET has introduced to make it easier for developing with an Oracle database, as well as to migrate it from SQL Client and SQL Server over to ODP.NET. And lastly, we'll talk about HA features for those who are looking to make their applications more highly available for their end users that can take advantage of many Oracle database HA features. So let's talk about NuGet first. And NuGet, for those who don't know, is a .NET software package manager. It makes it incredibly easy to install, to configure, and deploy .NET packages. It makes it also easy to find them as well. You just go to NuGet.org, or you can go from within Visual Studio, type in what you're looking for, and NuGet will bring up the best searches there. One of those of which is Oracle software. And when you find Oracle software, what it can do is figure out what dependencies you need, and for those dependencies, making sure you get the right versions, and then configure that all for you, so you don't have to do any hand configuration yourself if you install ODP.NET through OUI, for example. When you're done with it, you can then uninstall all your assemblies, and it will return your project state back to what it was before you installed them. So that's one of the nice things about NuGet, is that it provides a clean deinstall. The other thing that it does is that it only makes changes to your project. It doesn't make changes to any other parts of your Windows machine or globally. Components that Oracle supports with NuGet are ODP.NET Managed Driver and the ODP.NET Managed Driver for Entity Framework 6 and Code First. These two components are available on NuGet.org, and you can use them within your applications. They're fully supported. They are exactly the same as what you would get through the Oracle Universal Install. They're no different. It's just a different way for you to acquire them, and we update those on a regular schedule. In fact, we just updated them in June for the most recent ODP.NET Managed Driver and EF6. Next component we plan to include for NuGet support is the ASP.NET providers, and those will be coming shortly. Now, there's some features of ODAC that we can't enable with NuGet install, and that includes the Oracle Developer Tools. We can't include ODT as part of NuGet is that ODT makes changes on a global basis. It makes permanent changes to your Visual Studio setup. Because of that, it can't be a NuGet install. NuGet is limited to project-specific changes only. So where can you get the Oracle software from NuGet? You can first go to NuGet.org and do a search on Oracle. You'll find it that way. From within Visual Studio, you'll go to your references and choose Manage NuGet Packages, and there you can search for Oracle as well to find ODP.NET or the ODP.NET for Entity Framework package. If you want to download the NuPKG package in and of itself, you can go to OTN to do that. Many people might want to use this package on their own, not from NuGet.org, because they want to host it internally within their own intranet. Sometimes IT administrators want to limit what software you can install as an application developer. They want to vet the versions that they support that can be used. They can host NuGet server internally and host packages on there. What happens when you install the NuGet package? We'll actually do a demonstration of that, but let me just cover this. Because NuGet's intended to automatically complete as much of the installation process and setup for you, Oracle's NuGet package does the same. So we'll do most of the setup steps with the exception of a couple steps because it depends on your circumstances for how you set up your connection to your database. Most everything is set up for you. I'll actually show you the configuration information on what gets changed during the demo. What you actually need to change and be aware of, when you configure ODP.NET after a NuGet installation, you have to change the connect descriptor so that it points to the correct information of your database server, and the connection string with the right username, password, and data source name. You configure those two. They can be optional. You don't have to configure them in the .NET config file itself. You can certainly use other ways, such as using Easy Connect or using a connection string within your own application. Those are the common steps that some would use in their .NET config file to do configuration. So with that said, let's create an application using NuGet. Okay, so I'm in Visual Studio. And first thing we want to do is create a new project. And within this project, we're going to make it an ODP.NET application. So this will be a Visual C# console application. We say OK. And it'll create me a blank slate of an application for me to get started with. Now, normally I would search for ODP.NET in my local references for what's installed in the GAC. But since I want to use NuGet, I don't have to. We're going to right-click References and choose Manage NuGet Packages. So we can see that right there, Manage NuGet Packages. We'll choose that. And that will open up my connection to NuGet.org. So we're going to search online, all in NuGet.org, and choose Oracle. And when we choose Oracle, we can see a number of packages come up first. We see the EF package for ODP.NET and the managed driver for ODP.NET. If you just want to have a blank old ODP.NET application, you just pull this package in. If you want to create an EF6 application with the managed driver, you pull this in. And you'll notice that some of the dependencies included here, if we zoom in, we can see is that this works with EF6, so EF6 is a requirement. And then this also works for ODP.NET managed driver between 12.1022 and 12.2. What these dependencies indicate is that if I don't have EF6 or the managed driver, ODP.NET EF driver will pull those in automatically for you. And because I don't have them on the machine, if I click install, it will pull those in. So after I hit install, it'll ask me if I want to accept the licenses. I say OK. And when it says OK, it'll go out and it'll get the EF driver, it'll get the managed driver, and then it'll get EF6 assemblies and put them all inside my references. So it's done. We can see the README comes up. The README will tell me about new features, installation steps, installation changes, documentation that's come up. If I look at my references, I'll see several new packages being added. We can see that Entity Framework 6 has been added, Oracle.Managed Data Access, Oracle.Managed Data Access.Entity Framework. So that means I now have the references to develop an EF6 application with Oracle. That's been all taken care of automatically. I mentioned that configuration changes were made, and because they're local, they're going to be in your app.config. We can see our app.config is much more verbose than it was when we started the application. The default one is usually very short. Just to go over this briefly, we have a section handler we are introducing, the Oracle.Managed Data Access.Client section handler. And a lot of this stuff you normally don't have locally. You would have in your machine.config if you install ODP.NET in a machine-wide configuration. But because we can't rely on ODP.NET necessarily being installed already, we have to put the section name inside your local config to ensure that it gets read if you're doing any managed driver configuration. So that section name gets added so that it uses managed ODP.NET. We also add a provider here for Oracle.Managed Data Access Client, and we have the Entity Framework services here added to it. A factory class has been added, or factories. We have ODP.NET Managed Driver added, and an assembly binding redirect. So notice that for this assembly binding redirect, this version locally that was installed will override any other version that's been installed on the machine. Keep in mind, this will override all of the versions there except if you have the same version installed in your GAC. So if you have this same version in your GAC, obviously the GAC version will be used. So keep that in mind. And as you saw, we had defined this Oracle.Managed Data Access.Client section to define a specific configuration for the managed driver here, and we're going to do that right now. One thing we want to set up is the data source alias, and the data source alias we're going to call Oracle, and this will be our Oracle Connect Descriptor alias that we want to use to connect to the Oracle database. So this is something you would need to change specifically to connect to the Oracle database. Either define it here, or you could define it in your connection string in your application. So it happens to be that our service name is ORCL, just like I have. We're using the same port number as the default, and it's a local machine, so we can keep it localhost. So no changes there. Next thing I want to take a look at is the connection string section, and we have an Oracle DB context set up. In this DB context, we're going to connect to it, the HR schema when we build the application, so we'll set up the username and password for that. And then the data source is defined as Oracle, which we've also defined here. So everything is all set up and perfect for me to build an Entity Framework 6 application. We're going to do that later on, but this is all I needed to do to set up my NuGet package to connect to Oracle. You can see it was very quick. I didn't have to have anything installed ahead of time. NuGet figured it out all for me. So to recap, I opened up the package manager from the Visual Studio project. I selected the NuGet packages I want by searching for Oracle. ODP.NET Entity Framework Driver automatically pulled in my dependencies. I clicked on the install button and accepted the license. You want to keep in mind that the OUI ODP.NET versions won't override your NuGet install unless it's the same version. We do the assembly version redirect because we want the local to override what is on the global. And then we change the app or web config file to configure your connection string and the connect descriptor. And that was basically it. So let's talk about Entity Framework, since that's going to be the second part of this demo. What changes that Oracle has introduced with EF. The first major change we introduced was EF6 certification. So that's something that we've supported not only with ODP.NET itself, but with also the Oracle developer tools for Visual Studio. If you're using ODP.NET, it works with EF6. We have that as a separate ODP.NET certified EF6 provider. And then with the tool side, what we introduced is support for both database first and model first scenarios, so that the tools can provide an EDM wizard or generate the SQL statements needed for model first behavior. An additional feature is code first, the ability to use code-based modeling rather than using database first. With code first, you can create a code-based model, and that code-based model then gets reflected in the Oracle database based on the model. Because it's a code-based model and defined in a .NET, Oracle will have to make some assumptions on how you want that represented in the database. And we do that by convention. So we support code-first conventions. For example, a convention may be if the first property in that class that you want to store in the database has the word ID, Oracle will figure out, hey, this is going to be primary key. This is going to be an identity column if you're using Oracle Database 12c. So it will make it as such. Without having to do any extra logic or any extra definitions, we'll support that. And that's by convention. That's what Code First does. That's something that Microsoft has made available, and Oracle supports that. Certainly, if you want to change some of that behavior, such as data type mapping between what .NET represents on the code-based model and what Oracle represents in the database, you can change that through data annotations or the Fluent API. We support that as well. As you develop your application, you will end up modifying the model as you go along, as business requirements change, as you add more properties or eliminate a few. And we support that through code first migration. So if you change your code-based model, Oracle will then make those changes in the database to reflect that model. Let's take a look at how we use code first. And obviously, I'm already using Entity Framework 6. And the first thing we want to do is let's save these changes here. We go to our program. And I'm going to cut and paste some code. And let's take a first look at the classes that we're defining for our model. We have two classes, an employee class and a department class. In the employee class, we have the employee ID. And the employee ID will represent the primary key. And it knows that because it has the word ID in it. So that will automatically get handled. We'll take a look at that when that gets created in the database. We have a name for the employee, and we also have a hire date for the employee. For department, we have a department ID, the name for the department, the manager ID of the department, and the manager. We've defined a very simple set of classes. Each of these will get represented as a table in the database, an employee table and a department table. And then we create a database context based on that. we're going to create this model within HR, as we've defined here, the HR schema, and that should be it. It should get created. But let's add some data to it. Let's do something to these tables to make it a little more interesting, and that's what we're going to do at the beginning of this program. Now, what we do here is we're going to connect to this database context, which we've defined as the HR schema, and we're going to create two new entries, one for employee and one for department. And in this employee, we're going to create Alex and the hire date of now. We're going to create in the department tables the product management category and give them the employee ID that we have. Alex will be the manager for that. We add the employee and we save the changes. We add the department and we save the changes. Very simple. Let's run this and see what happens. So we'll run the application. It should create the schema. It should then add the data to the two tables, and then it should complete. Just say press any key to continue. Say OK. And now let's take a look at our schema and see what's changed. Right now you don't see the employee or departments table, and it'll have the same capitalization. So if we refresh, we should see that come up. And you should see actually three tables. You see employees here. You see a couple above that, departments, the one with the lowercase, which is the one that was created. And then you also see a table called underscore migration history. Underscore migration history just keeps track of the changes you make to the schema based on code first migrations. So if you make a change, it should get represented as another entry in the migration history table. Let's take a look at the employees table and the departments table here. So if we retrieve the data, we should see the Alex entry there, and we do see Alex being inserted. And then we look at departments, and we should see the product management category inserted. And we see it there. So perfect. It's got done. So you can see a very simple code first application we created with EF6, and through NuGet we installed it all and set it up. It didn't take more than a few minutes for me to do it all. Certainly coding will take longer, but the grunt work of doing the setup was very fast. Then it allows you to focus more on developing your application rather than learning how to set it up, finding dependencies, things like that. Now, I told you we would take a look at some of the schema itself with an employee. So let's take a look at the design view here. And we can see by convention what was automatically generated, which is the first column being an ID column, is a primary key. You can see the little key here, employee ID. It's not null. And an identity column was generated for this because you can see the identity checkbox be marked. We can see by convention it's automatically set up for you. It saves you a lot of the work of having to manually produce it. Very, very simple. Now, what about altering your code-based model? As you go along, you need to make changes to it. Now, through code first migrations, we can do that. So if I go back to my model and say I want to add a location property here, we'll uncomment this. This will be a string. Now, you can do a number of things. The newer way is just to run things, and Entity Framework 6 will automatically recognize it. But you can also use the Package Manager console, which is a more traditional way. We can go enable migrations first. So I'm going to type in enable-migrations. You can see it here. And it should enable migrations for me so that we can apply this change to the database. So it looks like it completed it successfully. So we'll add migrations, and we'll just call it first. We'll just give it a name first. Add migration. So, oops, I mistyped it. I typed migrations. Let's do that again. Add migration. There, it's successfully completed. Then we'll do update database. So the scaffolding has been all set up. We'll apply the change to the database by typing update-database. Now it's done. We'll take a look at the table now, and we can see the location column has been added. Perfect. Just like we wanted. And if we look at the migration history table, we can see that two migrations have been done. One is the first addition of the model to the database, and the second one is what we added in the location property. So it all gets recorded in the migration history table. So you can see very simply ODP.NET Entity Framework Code First is supported, Code First Migrations is supported, all how it ties together, and it works well. So I want to also point out some of the changes we make in order to support EF6, one of which is the new assembly. There's actually two versions of this assembly because we have a managed driver and an unmanaged driver. The managed driver's assembly is called oracle.manageddataaccess.entityframework, and the unmanaged one is called oracle.dataaccess.entityframework. The version for it is 6.12120. The 6 part is due to the EF6 support, so it follows whatever entity framework version is being supported. And then the last digits, of course, reference the Oracle 12c release. The reason why it's been separated out, this entity framework assembly specific for each data provider, is that it provides a clean separation among the EF and the rest of the data provider code. And it's something that Microsoft implemented after EF5 for EF6 and later releases, and provides a much cleaner support because now we can say update our EF6 driver and you don't have to change ODP.NET necessarily. Another change that we've instituted is the default mapping of Boolean and byte is different. In Entity Framework 5, the default Oracle data type mapping for numbers with precision 1, 2, or 3 was to an int16. EF6 has a new behavior. A number with precision 1 maps to a Boolean, and number 2 or 3 maps to a byte. That's the new default behavior. Oracle made this change to be more in line with what Entity Framework 6 does by default. You can retain the old behavior that you had in EF5 if you want to. You do that through using customized data mapping. There's a new way to do that as well with EF6. We introduced a new configuration settings in order to do that within your XML file and your .NET config file. And the changes you see here are in red between EF5 to EF6. We have this EDM number mapping section for a net type bool with min precision 1 to max precision 1, map it to or Oracle DB type number. So that's back and forth. So an Oracle number that has a precision of 1 will map to a bool, and a bool will go to an Oracle number of precision 1. For a byte, we do 2 and 3 to a number and back and forth. The attributes of these mappings are here. DB type represents Oracle database type. Net type represents the .NET type, min and max precision. So if you want to restore the old behavior, you can by using this. Or if you want to create your own custom mappings, you can do that deciding how you want your numbers to map from .NET to the Oracle database. Now, if you're converting from EF5 to EF6, Oracle follows the conventional method to do the conversion for any EF5 app to EF6. But let me cover it just so that you know. This is also covered in the Oracle documentation if you're upgrading from an Oracle EF5 app to an EF6 app. These are the things you would need to do. First, uninstall EF5, then install EF6. You can do that through the Package Manager console. Then you want to change the namespaces, 2 of them specifically, the data.entity client and the data.objects. Change those to data.entity.core.entity-client and the data.entity.core.objects. Those are the namespaces you need to use for EF6. After that, you go to the provider section and then you add the EF6 configuration in that .NET config section. This is automatically handled by NuGet, so if you install ODP.NET through NuGet, you don't need to worry about this. If you don't and you need to know what the syntax is, you can look in the Oracle doc. We have it there. You can copy and paste it from there. Another thing that's automatically handled by NuGet is the adding the reference for the EF6 Oracle ODP.NET assembly. That you have to do manually if you don't use the NuGet package, but if you use the NuGet package, we add it automatically for you. And then lastly, if you want to keep the old default behavior, instead of mapping to Boolean and byte, you would use the data type mapping, which I just showed you, to map it to int16 instead. Those are the key major things we added to Entity Framework support, but there's a lot of other things that we've added which can be significant to users. Those include the ability to automatically generate ref cursor metadata through the tools. Whereas in the past, if you're using a ref cursor with Entity Framework, you would have to generate that metadata manually to describe the ref cursor and all the columns that are being returned for that ref cursor. Well, as you describe it, it could have been error prone, so sometimes you would make a mistake and then you would have to figure out what mistake you made. Now, by having this auto-generated for you by the tools, you no longer have to worry about making a mistake. It becomes much more efficient for you to return these implicit result sets back from Oracle to Entity Framework because they eliminate the manual data entry. We also support Boolean data types now with ODP.NET, so now you have the Oracle Boolean type. We also support the ODP.NET Managed driver. You can use that with your Entity Framework support. Those were the features available for all database versions. Specific to database 12c are a couple new features. We support the identity column now with the Oracle database. We also support the SQL apply keyword for lateral views. So apply is a SQL Server specific keyword, and Entity Framework through LINQ, language integrated query, generate this apply keyword in its syntax when generating SQL. Obviously, this would generate an error or earlier versions of Oracle. What we've done with database 12c is introduce the apply keyword so that lateral views with apply are supported with the Oracle database. That way, when Entity Framework and LINQ generate the SQL apply, you no longer get an error, but a valid return of your results. So that's one of the nice things we introduced with Entity Framework. Let me talk a little bit more about this implicit ref cursor and how it generates the metadata. And I'll show you a demonstration of this. Instead of hand coding, you would use the Oracle developer tools. While you're in your Entity Framework project, you would just run the stored procedure from Server Explorer. The stored procedure is going to be returning one or more ref cursors. To be able to get that implicitly, we still need the metadata inside the .NET config file, but the tools are going to generate that metadata for you so you don't have to do it by hand. To do that, there's a couple things you need to do. One is to select the for config box, and that'll collect the select list for you and the metadata around the select list. And then the add to config button, which puts all that information, all that metadata information into the .NET config file. And that will eliminate all the hand coding of your metadata. So let's take a look at that and how that happens. So we'll go back to Visual Studio. And I have this stored procedure here called update and return salary. We'll double click it and take a look. So what this does is the important part is we're returning a new salary ref cursor as an output. This is going to go to an Entity Framework application, and Entity Framework is going to rely on an implicit result set. So we're going to need to generate some metadata for this. So let's see, we generate here with this open statement, and then the select statement returns two columns of first name and salary from employees where there's a matching criteria here. Okay, so let's carry through those steps I described. One was to run the stored procedure, and we'll just right click on it and choose run. You can see here. So let's choose run. We say okay. We don't actually need to add any valid values. We just care to get to the next screen. And first thing we want to do, well, the first thing I want to do is show the config. You would probably click on select for config first and add to config. Those are the only steps you need to do as I described in my slides, but we're going to do it a little bit differently because I wanted to show you what's happening. So we're going to show config just to see what would be added if I had clicked the add config right now. And we can see there will be in this the Oracle.Manage Data Access Client section because I happen to be using the managed driver here in my Server Explorer. If I were using the unmanaged driver, it would generate the Oracle.Unmanaged Data Access Client section instead. And this will apply to all version numbers, but we can certainly change that if you want. And it's going to be an implicit ref cursor with the name of the stored procedure and the name of the ref cursor. So that's great. Now we need the select list. So we're going to choose this box here, select for config, and the select list gets added. You see the metadata information here. First name, salary, column 0, column 1. First name is a varchar 2, provider type double for the salary, and additional information after that. It looks good, this configuration. I'm going to add it to my .NET config. So it says I'm going to add something here. We say OK, and we can see that right here, this block has been added. And I didn't need to hand code anything. It was very simple to do. For every ref cursor, I would carry this out. It's very, very simple. No more hand coding, which I'm sure everyone is happy about. Let's talk about some of the ease of development features. So it's not just we're adding these ways to better integrate with .NET, NuGet, make it simpler to deploy. We're also going to make it easier for you to develop. Part of that was what you saw with the pluggable databases and also the schema compare. We have additional ODP.NET features to make it simpler to develop. Let's start from the beginning in your experience with ODP.NET, and that would usually be installation. So how have we made installation easier? We've actually made it more configurable for those to have ODP.NET set up the way they want. We have this new non-machine-wide configuration install. So by default, Oracle in the past has always installed machine-wide. That is the ability to put odp.net in the GAC and changing your machine.config to handle odp.net globally so that it wouldn't have to go in your app config. So it would have a configuration section handler, it would have provider factory information. All that gets changed in machine-wide config. That's happened from the earliest ODAC days up to even ODAC 12CR3, and that is still the default. That is still the default behavior. Now, there are groups of users who don't want that to be the default behavior. They don't want odp.net to be gagged. They don't want changes to their machine.config. They would like to handle it themselves. They don't necessarily want every application to use the latest version of odp.net they install. With the non-machine-wide option, what you can do is choose not to have it installed machine-wide, which means nothing gets put in the GAC and we don't make those changes to the machine.config. Right now, the behavior by default is do machine-wide, but in the future, we may change that default to non-machine-wide since more and more users preferring the non-machine-wide install. Now, keep in mind, whichever one you choose will not affect Oracle Developer Tools. Oracle Developer Tools uses odp.net in the background to make its data connections, but whether you choose machine-wide or non-machine-wide, odp.net will still work just great with the tools. That's because the tools themselves get changed in their own local configuration settings, and that does not affect your application. So don't worry about the tools. They'll be just fine whichever option you choose. Another thing we introduced is a unified .NET configuration file format. We've seen with the introduction of more and more settings and attributes in the .NET config file, the legacy Oracle.DataAccess.Client format is not that great for it. We kind of put it all in kind of one super subsection. And users, as it grows, would like better classification of sections so that they can keep track of what information is for UDTs, what information is for the ref cursor section you just saw. They want to keep that in its own categorization of areas, and it makes it easier to read, easier to understand what's being changed. We've done that with this new section, both for managed odp.net and unmanaged odp.net. With unmanaged, it's oracle.unmanaged.data-access.client. That's a new .NET config section, the XML tag for it. And then for managed, it's oracle.managed.data-access.client. The unmanaged and managed, these two formats that are new, have the same elements and values, and the same subsections that you use. Everything is simple in one scheme, meaning if you're moving from managed to unmanaged, all you need to do is change unmanaged data access.client to managed data access.client, and everything will work. Everything should just work simply. With the caveat that as long as the features that you have in unmanaged are also supported in managed, which all of them are not. UDTs are an example of one that's currently not. As long as all the features are there, configuration should not have to change at all. We'll still keep the legacy oracle.dataaccess.client format if you want, and we'll still add to that with the new features. That will all still be there if you're using it. We expect more and more users to adopt new applications with the new format because it's easier to keep track of all the attributes and elements. What are some of the other features we introduced that are for programmers to use? One is the Boolean data type. This is something in odp.net, and it's called the Oracle Boolean. We support PL/SQL Booleans now, which means that if you have a PL/SQL application and it passes a Boolean data type to odp.net, we can use that. We can bind that as an Oracle Boolean. We can take that from a stored procedure. We can use that from an Entity Framework function import. Keep in mind, this is a PL/SQL Boolean. It is not a database Boolean. There's no Oracle database Boolean type. You can't put a database Boolean type in a table. You can only put a Boolean type with PL/SQL. So you can use this Oracle Boolean type with that. This is for unmanaged odp.net only, also keep in mind. Another feature that we have is the identity column. You can use the identity column, which you saw in Entity Framework. That supports the ANSI identity keyword. It makes it much simpler now to use this kind of the concept of identity column rather than having to create a sequence and a trigger. You can just create a plain old identity column. And actually, it's quite robust in 12c. There's a lot of ways you can configure this. Identity columns not only with odp.net, but with the tools as well. When you create a table, we'll automatically increment identity column. You can have the identity column there. You saw that option when we looked at the identity column within Entity Framework, in which the ID columns had a identity column checkbox, and odp.net will adhere to identity column values. And this is an ODB Oracle Database 12c feature. Just keep that in mind. Another feature that we have added is the ability to use large characters up to 32K in size now with the Oracle database, and you can use that with ODP.NET. So this is something new in Oracle Database 12c. Varchar2s, for example, used to be up to 4K, and now you can store them up to 32K. Before, you would have to use Oracle Lobs to support larger character data types. Many people may not want to use it. They want to use a simpler type. There's some overhead with using lobs in terms of programming against them. And people wanted, if they wanted to keep the data type simple, now they can. They can have up to 32K in size. You don't have to immediately just go to lobs if you have slightly larger string types. Now you can benefit from these larger types. With ODP.NET, there's no changes that need to be made on the application side. As long as you're using 12c, it will transparently be able to handle larger data types from the database without having to make any changes to your application. We've enhanced the implicit ref cursor support. One of those is what you saw with the Entity Framework demonstration, where we auto-generate into your .NET config. Another major innovation is the ability to use truly implicit result sets without even having to define that schema information that you saw. That's possible without Entity Framework. If you're not using Entity Framework nor user-defined types, we can generate this implicit ref cursor information for you with a new method of using ref cursors from PL SQL. When you use these implicit ref cursors, what can happen is that if you have multiple of them return, you can execute non-query against them, and it will return an array of ref cursors. If you execute reader, it will return you a data reader, and then for you to access the next ref cursor, you just say next result. The benefit is that you don't have to define all the metadata on the client side, declare all the types, but it will require some changes to your PL SQL development, since you can't just take what you have existing in PL SQL and make that implicit. It requires a slightly different way of calling your stored procedure output. So now you have this dbms underscore SQL dot return underscore result call with a cursor that gets returned. And this is how you get your ref cursor returned implicitly to ODP.NET or to any application. And I'll show you a code segment for how this all works together. If you're using, say, SQL Server moving to Oracle, this will support your conversion over using the Oracle and allowing you to use similar SQL client code and moving that to ODP.NET without having to declare your ref cursor at all. You can just maintain largely the same code as you were using with SQL client in ODP.NET. As I mentioned, Entity Framework still requires ref cursor metadata generation, but you saw how that was automatically generated. Let's see a code sample of this. On the left side, we have our PL SQL stored procedure. On the right side, we have ODP.NET code. So let's look at the left. The procedure is called getEmp and dept. So we see that up top here, getEmp and dept. And then we declare two ref cursors being returned. Then we execute a SQL statement that returns a ref cursor. So it's just a simple select, two statements here. And then we call dbms underscore SQL dot return result with the result sets. Now on this .NET side, we're going to not have to declare the metadata for this. So we'll just get it returned and we'll read the results. Here we just create a connection, open the connection, create a command, declare the stored procedure, and it's of type stored procedure, and then we just execute. No parameters that need to be declared. And then we just read the data. This will read the first result set. We just write it to the screen. We get the results from the employee number and the employee name. And then when we're done reading that, we can read the departments table by calling next result. We read it and output the two values. So that's very simple, how to do the implicit result set. It's very compact amount of code, makes it simple to migrate over from SQL Server to Oracle with ODP.NET. It also makes it simple if you're just developing ODP.NET app to not have to declare all the information about the ref cursor itself. The last major thing we've done with making it easy to develop is we can return the row count for every array DML iteration. Before, you wouldn't get the count of number of rows affected for each input value. You would just get the total number of rows, but not the number of rows affected. Because of that, you might have some questions about, well, did all the values get inserted as I want? Was there an error, or was everything successful? Now you'll be able to know that. We have a new property that allows you to get that information. It's the array bind row count property, and it returns the amount of affected rows, which could be different from the total number of rows affected. That provides more information for you to make sure you execute your array DML correctly. The last major area we introduced in database 12c with ODP.NET is HA features, high availability. These are HA features for your application developer, not just for the Oracle database, but often work in conjunction with what's available in the Oracle database. The first thing is support Oracle Notification Service, or ONS. ONS is the way that fan messages get sent from server to client and have that communication between the two. FAN is fast application notification. It tells Oracle clients when, say, a node goes down, a database goes down, and if it goes down, to do fast connection failover. If a node is busy or our database is busy, a fan will send a message to the client telling it to limit the dispensing of connections to that busy node, instead dispense connections to other nodes that are less busy. And works great with RAC, works great with DataGuard. It's been significantly enhanced with the introduction of global data services, which I'll also talk about. ONS allows you to share those fan messages, and what ONS replaces is AQ. AQ was the prior way that we shared messages between client and server for FAN, but ONS has a lot of benefits. The benefits include it's faster, it's more scalable, it doesn't have a firewall issue between client and server. If there's a firewall between the two, that could stop messages from being sent. It supports active data guard, and it consolidates our publish subscribe service, because we used to have ONS and AQ, but now we're only going to go pure ONS. The great thing for the application developer in .NET is that there's no code changes required. If you were using AQ before, you can just move over to ONS without code changes. There are some configuration changes in how you set up on the database side and perhaps on the client side, depending on what combination you use of 12c, 11g, or 12c and 12c managed or unmanaged, but no code changes, just configuration changes, if any are necessary. Whether you're using ONS or not, if you're using ODP.NET 12c, you'll always use ONS except in one case. The one case is when you use unmanaged ODP.NET with Oracle Database 11.2 or earlier. That is the only time you still would be using AQ. Any other time, ODP.NET will try to use ONS for its communication. In terms of better ways to improve availability, planned outage becomes more graceful with ODP.NET. And what is planned outage? When you're using machines in your database, sometimes you want to bring those machines down. The problem is if you have users on the machines, how do you bring it down without disrupting their work? You could wait until there are no more users on the machines, but how do you enforce that? Well, with this graceful planned outage, we have an easy way to enforce that. What the DBA does, well, it will shut down and indicate in the shutdown that the server or the machine will continue processing work, but will not allow additional connections to it from other users. And once users signed off from the application, they will remain off, so that eventually all the connections will drain from this specific server or specific machine. What ODP.NET will do once it gets that shutdown message that the reason is the user initiated, meaning the DBA has initiated it, it will say, oh, okay, let me clean up all the connections in my pool. All the idle connections are removed from the pool to that specific machine. The other connections to the other machines or other nodes are not touched, only the ones for the machine that's going to go down. And any remaining users can continue their work to that machine, but when they return the connection to the pool, that connection will be destroyed rather than redispensed to another user. And the great thing about this is that new users could come in and they will be served by the other machines that are part of the cluster or part of the global data services or active data guard. They just can't go to that one machine that's going to be shut down. That's the great thing about this planned outage. You can use this as an application developer if you set HA events equals to true in your connection string. The great benefit to the end user is that they'll never experience an outage. You can be taking machines up and down, up and down. As long as you let them complete their work and then they move off the machine, you can bring down the machine without any end user being disrupted. And this is actually available back in 11.2. We just introduced it very late in 11.2, specifically 11.204 database and ODP.NET. But obviously it's in 12c as well, so you can use this with 12c. Another great feature we introduced is Transaction Guard. Transaction Guard solves the problem of determining the outcome of your transaction after a failure. So this is for unplanned failures of your database node. When you have a failure of the database, what happens? Well, you have to recover from that, and you have to figure out that the transactions that were in process, have they committed or not? Because when you have these in-doubt transactions, what you don't want to do is, if a transaction committed already, you don't want to execute that transaction again. If a transaction hasn't committed you don't want to be left without having that transaction actually commit. You actually want to know, well, you actually want to know whether commit or not. If it didn't commit, you want to carry out that transaction. So what this transaction guard feature does is it gives you an accurate knowledge of the transaction outcome after a failure. It tells you exactly what was happening upon that last connection and what is the transaction in that connection. Did it commit? Did it not commit? If it's in doubt, what part of it's in doubt? So that you can then accurately know what to do next in terms of resubmitting it or rolling back and resubmitting it or doing nothing because the transaction committed. How do we do that? We provide some new APIs beyond the logic that is already there within the database that was introduced in Oracle Database 12c. We provide some additional APIs in ODP.NET 12c for you to handle this. One is the Oracle exception object. After a failure, you obviously will get an exception. Because you get an exception off that object, you can then see if there was a transaction being in process of that connection, whether it's recoverable or not. And ODP.NET will give you a true false whether that transaction is recoverable or not if a transaction was in process. From that, you can then get a new Oracle connection object connected to the database and retrieve an Oracle logical transaction object based on the last Oracle logical transaction that was being committed or last transaction that was being in process. From that, we can get the transaction status, and that will give us the accurate status of what is the current state of it. Because when we return the recoverable, you may not know if maybe the transaction is in the process of committing, but we'll tell you for sure from the Oracle logical transaction the current status of the transaction, whether it's committed or it's not committed. And this is something that you need both Oracle Database 12c and ODP.NET 12c to use. So let's go through a scenario, including some changes we made for Oracle 12.102. In a typical scenario, you're going along with ODP.NET, and then you get a fan error, an unplanned scenario in which one of your nodes failed. And this is a fan down event. After the event, you can add some application logic in the exception, the Oracle exception, asking, is recoverable this property, is it true or is it false? If it's not recoverable, you're going to have to roll back. If it is recoverable, you can possibly resubmit the transaction. Let's act as if going through the scenario of resubmitting. To resubmit, we would go then reconnect to the Oracle database. So we use the same credentials to connect to the Oracle database. And then we retrieve the Oracle logical transaction object that is part of the Oracle connection object. From there, we can then retrieve the transaction status by calling getOutcome off Oracle logical transaction. And the getOutcome will then tell us if the transaction committed and completed, at which point we know we're done. We don't have to do anything because it's done. It's committed and completed. If it's not committed nor completed, we're going to have to resubmit it. So you can then have application logic go resubmit it. We have a code scenario inside the documentation to show you how you do that. So look at the documentation to see how the scenario carries out for an example. So that was Transaction Guard. With Global Data Services, what we provide is extending RAC beyond just your RAC cluster, but to a global level. Meaning you can use DataGuard, you can use Golden Gate, you can use other RAC clusters in any data center around the globe you have access to and participate as a database server serving your applications. So you may have a data center in Europe, one in Asia, one in North America. Your users can go to North America, or they can go to Europe, or they can go to Asia. And you might want, even people in North America, users in North America, might want to go to European or Asian data centers if the North American servers are heavily loaded and they can't serve the connections very quickly because they're maxed out in terms of the usage. It may be faster going to Asia or to Europe to dispense a connection there and provide the service there if it's the middle of night there and they're not being used. So it allows you to globally take advantage of all your hardware around the world and really optimize that. And it doesn't just have to be RAC, as I mentioned. It could be Active Data Guard, it could be Golden Gate, all participating in these. No code changes are required on the ODP.NET to take advantage of this. What really you need is just configuring GDS. As long as you're using FAN already, you don't need to make any code changes. It does require ODP.NET 12c and Oracle Database 12c. And with that said, that concludes this presentation of new features introduced with Oracle Database 12c and ODAC 12c for .NET developers. I want to thank you for joining. We will start the next presentation on best practices for .NET development and Oracle shortly. In the meantime, feel free to ask questions in the chat window, and we'll try to get to all of them. Thank you.